Hey guys, welcome back. Today is day 12 of this 30 days Leetcode challenge, and I feel the quality of questions has been improving. So, today's question is last stone weight. So, let's get started. We have a collection of stones. Each stone has a positive integer weight. So, we are given an array of positive integers, and those integers are the weights of stones. Now, each turn, we choose the two heaviest stone and smash them together. Now, if you smash two stones, in that case, there are three possibilities. Either the first stone is heavier than the second one, or both have equal weight, or the second stone is heavier than the first one. So, uh, if the weight of both the stones are equal, then both the stones are totally destroyed. But if the weights are not equal, then we'll be left with a stone that has a new weight of the difference between them. So that is what we are given, since the weight of the stone cannot be negative. So we'll be checking the absolute difference of the weight of the two stones. And now what we are told is we have to add this remaining stone back into the array, and continue doing this process, and at the end we'll be left with at most one stone. Now there is a possibility that we might not be left with any of the stone. Let's say if initially itself we are given two stones which have equal weight, then smashing them together will give us a weight of 0. So none of the stones will be left. So that is the reason they have added at most. Now, if you are left with two stones, obviously you have to continue smashing them, and until you are left with at most one stone, one or zero stones. So yeah, this is the example that they have given. So in this example, we are given different stones of different weights, and if you check, we are told to start with the heaviest stones that are present in the array. So in this case, the heaviest stone will be of weight 8 and of weight 7. And once you smash the two stones, you'll be left with a new stone that is of weight 1. So we'll add it back into the array. So initially we had two ones, and now we are left with three ones, and 7 and 8 are out of the array. Now, in this array, 2 and 4 will be the two heaviest stones. 4 will be the heaviest, and 2 will be the second heaviest. So, if you smash these two together, you'll be left with a stone that will be of weight 2. And if you continue doing it, uh, in the next iteration, you'll be smashing 2 with 1, and you'll be left with a stone of 1, weight 1. And when you smash the two stones of weight 1, you'll be left with a single stone that will be of weight 1. So, and this is what you'll be returning in this case. So let's say if there was if you remove one stone of weight 1, then you'll be left with no stones in that case. So that will be one of the test cases that we'll be trying out. Now, if you carefully look at this problem, this involves some sort of array sorting. So every time you'll be sorting the array, and whatever is the element at the extreme right. So let's say if you sort the array in ascending order, then whatever are the last two elements will be the heaviest stones in the array, the largest elements in the array, and you have to smash them together, and whatever if the result is greater than 0, then you add it back to the array, or if the result is 0, then you don't add it back to the array. So that is what. And once you add it back to the array, you have to sort the array again, and keep repeating this process. Now, if you think about how the arrays are getting manipulated, you'll feel that it is pretty similar to what max heap would do. So in max heap, you would be storing the element in the uh, you'll be storing the heaviest element at in the root, and when you try to poll two elements, you would get the heaviest and the second heaviest element. So Yeah, that is what, and we can keep smashing them and add it back to the max heap. And if the result is greater than zero, and keep repeating the process as long as our size of the max heap is greater than 1. So as long as the size is greater than 1, we'll keep doing this process. And if our size becomes less than equal to 1, in that case, we'll just check if the size of the heap is greater than 0, then we'll return whatever element is left in the max heap, else we'll just return an element of weight 0. So that is what I'm planning to do for I'm planning to write for this case, this problem. So what I'll be doing is I'll be creating a priority queue. So in Java, and priority queue is similar to heap, but by default the ordering of the elements in priority queue will be on a natural order. So if you just create a priority queue and add elements to it, what we'll find is the elements are sorted in ascending order. However, what we need is a max heap. So we want arrays to be sorted in descending order. So by default, the priority queue will create a mean heap, but what we need is a max heap. That is what I'm trying to convey. So we'll create this max heap, but since the default ordering of natural order can be a problem, so we'll have to implement a comparator to compare the elements of the array. So I'm passing in a comparator, and it will contain a compare method, and which will take two integers I1 and I2, and what I'm going to return in this case is I2 minus I1. So this will ensure that our priority queue uh, will contain the elements from in descending order. The maximum element, the heaviest element, will be present at the top of the priority queue. Now we have to add all the stones to our max heap. So what I'll do is I'll iterate through each of the stone that is given in the array, and I'll add it to the max heap. Okay, and now all of our stones are added. So we have to keep removing the elements as long as the size of the max heap is greater than 1. So, and what we'll do is we'll take h1, the heaviest element, and what we'll do is poll the element. The second element will be h2, which will be again polled from removed from the max heap. And what we'll do is find the diff, and we have to use we don't have to use absolute in this case, because we know h1 will contain the max, and h2 will obviously be less than or equal to h1, so that our diff will be greater than or equal to 0. And we just have to check if the diff is greater than 0. In that case we have to add it back to the max heap. So we'll add the new stone if it's if after destroying the two stones, if we are left with something, then we add it back to the max heap. And we keep doing this as long as the size of the max heap is greater than 1. And when we come out of the loop, the size of the max heap will be less than or equal to 1. So we have to add a check here, which will say if the size of the max heap is 0, then there is no element left. Otherwise whatever is present in the max heap, we can just remove that element and return it. So yeah, this should work. So let's run it and check for the default test case that is given to us. Okay, there is some compiler error. Oh, the comparator. This is actually a method. I forgot to add two round brackets. And is there anything else? No, this does not seem like a problem. So yeah, yeah. So our solution ran successfully, and it is giving us the answer. Now let's try it by removing one. Sorry. So I have removed one one stone that was of weight 1. In this case, all our stone should smash and our answer should be 0. So our test cases are running. So let's submit this and check if our solution gets accepted or not. Yeah, our solution is accepted. Let's see how well it performed. Oh, we are told that our runtime beat 6.7% of Java solutions. Let's try let's try submitting this again, because earlier when I submitted, it said it was the best solution. Uh, so I don't know how this metrics are found, but yeah, let's try it again. Uh, uh, I don't know, for some reason it is now showing that it's not beating that. But my previous submission was showed me this. It was in the top 95% of the accepted solutions. So yeah, I don't think there is any problem as such. This is a proper solution, and we are iterating through the array only once. And yeah, we are using an additional memory, but that helps us avoid sorting the array again and again. So yeah, uh, let me try submitting this again. Yeah, see, now it is showing the solution beats 91% of Java submissions. I don't know how this works, but yeah, our solution is the best one for now. So thank you, and if you like the video, give it a thumbs up and subscribe to my channel. And yeah, uh, if you want to be notified about when I upload the solution to the 13 problem, do click on that bell icon as well. So thank you.